Hello friends. In one of the video we have discussed about chemical shift and position of signal. We have also discussed about shielding effect and this deshielding effect. Again, shielding effect is the effect when the induced magnetic field is in the opposite direction of the applied magnetic field, and when the induced magnetic field is in the same direction of applied magnetic field, such signal or such effect will be called as deshielding effect. This shielding and deshielding effects are in the position of NMR absorption is due to the some reference with some signal with some reference is taken, and one of such reference signal is of tetramethyl silane, that is also known as TMS. And this TMS is why it is called taken as a reference, because it has a very strong shielding effect amongst all the aromatic organic compounds, and the difference of the absorption position of the proton with respect to this TMS signal is called the chemical shift. Here we are talking about delta value and tau value. Why TMS is considered as a standard reference? There are some characteristics. It is easily miscible with most of the organic substance. It is very highly volatile. That is very low boiling point, and thus it can be readily removed with the sample. And third, it does not take part in any of the reaction or intermolecular association with the sample. This is the 3D the structure of tetramethylsilane. This is the silane Si, and these are the four CH3 which are arranged at the tetrahedral positions. This is the view of the electron density, or we can say shielding effect. As you can see, these protons here are highly shielded. All the protons of methyl groups are highly shielded. The fourth methyl group is besides this, because it is situated at the tetrahedral point beside this silicon. So due to this high shielding effect of these all methyl groups, protons of these methyl group, these TMS signal is the observed at very low and almost at 0 delta ppm. So let us see what are some more reasons why TMS is selected as the standard. As I said, it has a high shielding effect. This is also due to very low electronegativity of silicon, and the shielding of all these equivalent proton is greater than any other organic compounds. The next can be the proton resonance of organic compounds. The majority of organic compounds protons resonate flips at lower field compared to TMS. Third one, TMS has large number of equivalent protons. That means it has a very high shielding effect, resulting in the resonance at a very upfield, and thus the upfield absorption spectrum is observed as if they considered as at zero delta value, and any other set of proton which absorbs the uh, field lower than that delta value, it is giving a positive delta value and with respect to compared to TMS, and the tau value and delta value is has the relation tau equal to 1 minus delta. This is the scale of delta and tau value. As we know, delta and tau value are inversely proportional, and due to high shielding, TMS gives a signal at high delta value. Let us see what is the effect due to high shielding. Highly shielding, if high shielding in any proton or any molecule, the signals will be observed at lower delta value, and or it can be said as upfield, because it will need, as it is highly shielded, it will need large amount of field. The proton will need large amount of field. Upfield means, the shielding means the induced magnetic field is in the opposite direction of applied magnetic field. So it will need, the proton will need more amount of field to get flipped. So the proton, the signals will be observed at upfield in case of shielding effect. And we are talking about deshielding effect. The secondary induced magnetic field is will be in the direction of applied magnetic field. Thus these protons will give absorption band at higher delta value, and it is said at downfield. So it will need less amount of field to get flipped. So this is all about importance of TMS, shielding and deshielding, low field and high field. Thank you.